Good morning, everyone. Today we're going to continue our work with fractions. We're going to see that there are a variety of different things that we can do with fractions. We can see them as a division expression, a regular fraction, a mixed number, and two different ways that we could do them and show them as a division problem. In the first one, we see 5 divided by 4. So when we write that as a fraction, we will notice that 5 is our numerator and 4 is our denominator. Okay? Now, the number 5/4 as a mixed number, okay, would be 1 and 1/4. Okay, so what you should realize or remember about that is if 4/4 is 1 whole and you have 5/4, you have 1 whole and 1/4. Now, I'll show you that as a regular division problem. Okay, so if I was doing this and I went 4 is my divisor and 5 is my dividend, 4 divides into 5 one time. 1 times 4, of course, is 4, so I would write it underneath, and then I would subtract. Now, usually, we would write as a remainder of 1, but we're not doing remainders. So what we're going to say is that 1 that looks like my remainder would become the top number in the fraction, and my divisor, the 4, becomes the bottom number in the fraction. So that says 1 and 1/4. Okay, so again, when we've done this in the past and we've not been allowed to have remainders, we've known that we could write them as a decimal. So I'm going to write the same one. I'm going to write over this word or a little bit to save room. And if I did 4 into 5 this way, I would simply go, okay, 4 divides into 5 one time. 1 times 4 is 4. So I would write that underneath and I would subtract and I would have 1. Now again, we do not want to have a remainder, so we need to change it to a decimal. In order to do that, we should know to add a decimal and a 0. Now we can bring the decimal straight up and the 0 straight down. Now we divide. 4 divides into 10 2 times. 2 times 4, of course, is 8. So if I subtract that, I get 2. It still did not come out. So I'm going to add another 0 and bring that down. And now I can divide 4 into 20. 4 divides into 20 5 times. 5 times 4 is 20. So we are done. So that says 1.25, which we would read as 1 and 25 hundredths. It just so happens that 25 hundredths would simplify to 1/4 or 1/4. So these are equivalent. 1 and 1/4 and 1 and 25 hundredths are the same thing. In the next example, we see 3 divided by 2. So as a fraction, that would mean 3 over 2. So we already realize that this is going to be bigger or larger than 1 whole. So 2 halves would be 1 whole. So if I have 3 halves, I have 1 whole and 1 half. So setting that up as a division problem, 3 divided by 2 means 2 is my divisor and 3 is my dividend. So if I go ahead and divide this now, I would go 2 divides into 3 one time. 1 times 2 is 2. I write that underneath and subtract, and I get 1. Again, we're not having remainders. So that 1 that looks like a remainder becomes the numerator, and the divisor, which is the one we are dividing by, the 2 becomes the denominator. So we can see that that is indeed equal to 1 and 1/2. So if we were doing the same problem as a division problem, that means it would look like this. As a decimal. So we would go 2 divides into 3 one time. 1 times 2 is 2. I subtract, I get 1. Now I'm not going to allow you to have a remainder of 1. We are going to change this to a decimal. In order to make that happen, we must add a decimal and a 0. Now I can bring the decimal straight up and the 0 straight down. Now we divide. 2 divides into 10 5 times. 2 times 5 is indeed 10. So when we look at these problems, We will see that when we did it as a mixed number or a regular division problem, it came out to be 1 1/2. As a decimal, it came out to be 1 5/10. Well, it just so happens that 5/10 would simplify to 1/2. So 1 1/2 and 1 5/10 are indeed equivalent. In the next problem, we see 6 divided by 4. So if I'm writing that as a fraction, that would be 6/4. So again, 4/4 is equal to 1 whole. So if I have 6/4, I have 1 whole and 2/4. And we should know by now, after doing almost 3 months of fractions, that this will simplify to 1 1/2. So if we go ahead and set this up and do this as a division problem, 4 would be my divisor and 6 would be my dividend. So we would go 4 divides into 6 one time. 1 times 4 is 4. Right underneath it, subtract, and I get 2. That looks like a remainder, but again, we're not having remainders. So the 2 becomes the numerator, and I divided by 4 as my divisor, so that becomes my bottom number. And we know that 1 2/4, we've already done it in the previous one, is 1 1/2. Now let's look at this same problem doing it as a decimal. So if I was dividing 4, which is my dividend, that's my divisor, into my dividend of 6, 4 divides into 6 one time. 1 times 4 is 4. I subtract, I get 2. I'm not allowed to have a remainder of 2. So if I'm doing it as a decimal, I would add a decimal and a 0. Now I can bring the decimal point straight up, the 0 straight down, and divide. 4 divides into 20 5 times. That, of course, goes evenly. So if you look at that, that also became 1 5/10, which is the same as 1 1/2. In the next problem, we see 9 divided by 4. That means that 9 is my numerator and 4 is my denominator. So if I think about this, if I know that 4/4 is 1 whole, then I should know that 8/4 would be 2 wholes. So if I have 9/4, I have 2 wholes and 1/4. If I go ahead and do this as a regular division problem, so that means that 4 would be my divisor and 9 would be my dividend. So when I go ahead and do this, I would go 4 divides into 9 2 times. 2 times 4, of course, is 8. If I subtract, that gives me 1. Now again, we're not having remainders, so that 1 can become the top number in my fraction, and the 4 becomes my bottom number in the fraction. So we see 2 1/4. Now wait a minute, I've seen 1/4 somewhere before. If I look up in problem number 1, when I divided that one out, the answer was 1 1/4, and as a decimal, that meant that that was the same as 1.25, or 1 25/100. If I was a betting man, I'm guessing this answer is going to be 2 25/100 as a decimal. Let's go ahead and see if that is indeed the case. So when I set this up, 4 is my divisor, 9 is indeed my dividend. 4 divides into 9 2 times. 2 times 4, of course, is 8. That would give me what looks like a remainder of 1. Well, I can't have a remainder, so I'm going to add a decimal and a 0. A decimal, oops, just a 0 down there. I'm going to bring my decimal point straight up. 4 divides into 10 2 times. 2 times 4 is 8. If I subtract, I get 2. I might be running out of room, and you might not be able to see that. But I do have 2 down there. I can't have a remainder of 2. So I'm going to add another 0 and bring it down. Now if I divide, 4 divides into 20 5 times. So I was indeed right with my original idea that it would be 2.25. And of course it is, because 1/4 is equal to 0.25. We're going to learn that in future lessons. So 2 and 1/4 and 2 and 25/100 are indeed equivalent. In this next problem, we will notice that it says 1 divided by 2. So if I was doing that, I would go 1 is my numerator and 2 is my denominator. Now, in order to do that, okay, as a mixed number, I can't do it. So I'm just going to write NA, which means not applicable. You cannot do that. But I can still turn this to, or I can still make this a division problem. All right, so in order to do that, it says 1 divided by 2. That means 2 is my divisor and 1 is my dividend. Now you might say, well, Mr. Pierce, I can't do that. I can't divide 2 into 1. Well, if you think about it that way, you're right. But if you think that 1 whole is the same as 10 tenths, and we can make it say 10 tenths by adding a decimal and a 0 and now bringing it up, we see that we can do that. Okay, 2 does not divide into 1. We can put a 0 there. 2 divides into 10 tenths 5 times. So 5 times 2 is, of course, 10. So when we look at that, the answer is 0 and 5 tenths. Let's go to the next problem. So we see the number 3 divided by 4. So as a fraction, that means it's 3 over 4. Can that be a mixed number? The answer is no, it cannot. Okay, so I'm going to write not applicable for this one as well. But I can still divide. It says 3 divided by 4. That means 4 is my divisor and 3 is my dividend. If you remember what we did in the previous problem, we simply added a decimal and a 0 because we can say 4 does not divide into 3. But if I think of it as 30 tenths, now I can divide. So if I do this, 4 doesn't divide into 3. 4 divides into 30 7 times. 7 times 4 is 28. 30 minus 28, we should all know, is 2. Wait a minute, still didn't come out. So what do? We add another 0 and bring it down. Now we can divide. 4 divides into 20 5 times. 5 times 4 is 20. So what we should notice there is that 3/4 is equal to 0.75. Well, wait a minute. One of the ways that we can say 3/4 is 3/4. Well, 3/4 is 75 cents, which is exactly what that says over there. Let's go to the final one. We have 4 divided by 5. That means the fraction is 4 is my numerator, 5 is my denominator. Can I change that to a mixed number? The answer, of course, is no. So again, not applicable. So now we set this up as a division problem. It's 4 divided by 5. So that means 5 is my numerator, and 4, I said that completely wrong. 5 is my divisor, and 4 is my dividend. So, does 5 divide into 4? No, Mr. Pierce, it does not. So I'm going to change this to 40 tenths by putting a 0 in the tenths place and bringing up my decimal. Now I can go ahead and divide again. 5 does not divide into 4, so I'm going to put a 0 there. 5 divides into 40 tenths 8 times. 8 times 5 is 40. So we can see that that answer is 8 tenths. Well, just so happens if we were doing an equivalent fraction, 4/5 is 8 tenths. They are equivalent. I hope you find this useful. Again, another way to play with fractions, we can see that we can make division problems out of them. Eventually, we're going to be making, writing them as decimals and percents.